Hello friends, welcome back to Scientific Blunders, where you learn the don'ts first. So today we are going to explore what is a fundamental concept in probability and statistics known as variance, right? And for those of you who need a refresher on variance, variance is just the measure of dispersion of a random variable about its mean, right? So in more mathematical terms, the variance of x is the expected value of x minus the expected value of x squared. So what this means is x minus the expected value of x is also a random variable by itself, and it's the distance of the random variable from the mean. And so when you square it, it becomes positive irrespective of whether x is greater or less than its mean. And then when you take the expectation of that, in some sense you're measuring the dispersion about its mean, right? So this is the definition of variance. And in this video, as you may have guessed, we are going to explore the concept of variance in both the traditional way and a more innovative and visual way as well. All right, so let's consider a simple problem, a very simple toy problem, because the simplest problems are often the best way to explain very deep concepts, right? So let's consider a random variable x that takes the values small x. Capital X is a random variable, small x is the values taken by the random variable capital X. So let's say it takes the values 1, 2 and 3 with probabilities. The probability that x takes the value x is 1/4, 1/4 and 1/2. So obviously the probabilities add up to 1 because we have covered all possible outcomes. And the variance of x, so this is a very simple problem, right? So I encourage you to pause the video here and compute the variance by yourself, the traditional way, just the way it's done traditionally. All right, so hope you're done trying and hopefully you got the answer. So I'm going to do this quickly because this is not the main purpose of the video, but if you were to expand this out, expectation of x squared plus this thing squared minus 2x times the expectation of x, this whole thing can be simplified to the expectation of x squared minus the expectation of x the whole squared, correct? And the expected value of x is just the weighted average of 1, 2 and 3 where the weights are the probabilities, right? So it will be 1 times 1/4 plus 2 times 1/4 plus 3 times 1/2. And I'm going to allow you to work that out yourself if you haven't done already, but the answer to that is 9/4. Okay, and this is the expected value of x. How do we find the expected value of x squared? Well, that's not too hard either, right? Because when x takes the values 1, 2 and 3, x squared is going to take the values 1, 4 and 9 with the same probabilities, right? So the expected value of x squared, right, I'm going to write that here. The expected value of x squared is 1 times 1/4 plus 4 times 1/4 plus 9 times 1/2, right? The weighted average of 1, 4 and 9 where the weights are the probabilities. And that is, how much is that? That is 23/4, correct? Right. So I'm going to leave these as an exercise for you because this is fairly simple and I want to focus on the main part of this video, right? And so the variance of x, all you have to do at this point is just plug in these numbers into this equation. So it's 23/4 minus the expected value of x the whole squared. So 9/4 squared is 81/16. And this, when you do the math, will give you 11/16, right? So the variance of x is 11/16, and that is the right answer. So I'm not going to tell you to pause the video and see if I've made a mistake, because I don't think I have. But this is how variance is traditionally explained, right? In this video, what I want to do is visualize the idea of variance, right? And when I first learned this, I was actually mind blown, because nobody had ever taught me to visualize the concept of variance or covariance. So let me scroll down a little bit first. Okay, actually, let me scroll all the way down, because I think we're going to need space. Okay, and what I do want is I need to have the definition of variance on the side, because that's something we are going to need as we try to visualize it. And I also want the uh, the the random variable, the information about the random variable on the side as well, right? So I think this is all we need. So the first thing to visualize anything is to draw a plot. So let's do that. And you might be confused at this point. What are we going to do with two axes when we have only one random variable, right? So I assure you all of those confusions will vanish by the end of this video. And on the x-axis, I want to plot what are the different values the random variable x can take. Well, it can take, let's use a different color. It can take 1, 2, and 3. So it can take three different numbers, 1, 2, and 3. And on the y-axis, this is where you're going to get confused, just like I did. I also want to plot the same thing again. So I mean, this is the y-axis, but I'm plotting the values of x here, right? So hope you understand that. So again, it can take three values, 1, 2, and 3. And right, I forgot to pull another piece of information from the top. What is the expected value of x? That is 9/4, right? So we will also, let's just keep that information on the side as well. Okay, so we have the definition of variance, we have the information about the random variable, and we have its expectation. Now let me also plot the expected value of x on this plot. So 9/4 is 2.25, right? So it's going to lie somewhere here. Okay, 2.25 is somewhere here, is 9/4, and it's somewhere here. And at this point you're just completely lost. Please be a bit patient, because everything is going to become clear shortly. And I'm again going to plot the same thing on the horizontal axis as well. Okay, so this is again the expected value of x, which is 9/4. And some of you may have already guessed what is going on, but let's instead of just expanding this algebraically like we did earlier to compute the variance, let's think about what this actually means. What does this term mean, right? X minus the expected value of x is the distance of the random variable from its expected value, correct? And you're squaring it, right? And remember, I said I wanted you to visualize squaring, right? So and this was also pretty amazing the first time I realized it. The word square, like let's say 2 squared is 4, it's basically another way of saying that the area of a square of side 2 is 4. And when you cube something, it's like saying the volume of a cube of side 2 is 8. So that's where the words squared and cube came from, which actually I had completely not realized for so long. But so coming back to the point, x minus the expected value of x, let's say 3 minus the expected value is this distance, and when you square it based on the hint I just gave you, you are actually finding the area of a square, right? And what square are we looking at? So we have 3, x can take on 3 values, which means x minus the expected value of x also can take on 3 possible values. And what are the 3 squares we are looking at? So the first square is the distance of 3 from its expected value squared, right? And if I had to visualize this on this plot, that would be somewhere here, right? Because this is the distance of 3 from the expected value. This is the distance of 3 from its expected value. And so this area, the area of this square, represents one of the 3 cases of x minus the expected value of x squared, right? And what are the other 2 cases? Well, the second random variable is 2. And what is its distance from the expectation? Well, this is the distance. And in the y-axis, this would be the distance. And so if we had to visualize this, this is going to be this tiny little square here. Somewhere here, right? Awesome. And finally, what is the distance of 1 from its expectation? Well, this is the distance of 1. And if we squared it, we are basically looking at this big square here. So now we are looking at this square. Okay. Yeah. I hope you get the idea. Okay, let me actually. It is supposed to be a square ideally, but you know, my drawing may not have been perfect. Okay, what I'm going to do, one last attempt. I don't want to waste too much time on. I'm going to make this as a rectangle and see if it allows me to resize. Yeah, exactly what I needed. So assume that this is a square, although it doesn't look like one. But this is the area that corresponds to 1 minus the expectation of x, the whole square. Okay, and now we want to take the expected value of that, right? So we are nearing the end slowly, right? What is the area of this squared? Right, so the area of a squared is just the side squared. So 3 minus 9/4 is how much? This distance is 3 minus 9/4, that's 3/4. Okay, this distance is 2 minus 9/4, which is 1/4. And finally, this distance is 1 minus 9/4, which is 5/4. Correct? And so what is the area of this squared? Well, it's 5/4 squared, which is 25 by 16. What is the area of this squared? Well, it's 1/4 squared, which is 1 over 16. And what is the area of this squared? It's 3/4 squared, which is 9/16, right? And now we just have to take the expectation of that, and that is nothing but the variance. So we have 3 numbers, 25 by 16, the area of this square, 1/16, which is the area of this square, and 9/16, which is the area of this square. And so what is the expectation of these 3 numbers? Let me put that here so that we have a little more space, and we are nearing the end of this end of the video, so that's getting me excited. The expectation of these numbers is just the average, right? Because we found 3 numbers, and now we want to take its expectation. So we just do 25 by 16, 1 by 16 plus 9 by 16, and it's a third of that. So it's the average of the area of the 3 squares. Is that correct? So that gives us 25 plus 1, 26 plus 9, 35 by 16, and then there's a 1/3, right? And does this match the number of that we got earlier? We got 11 by 16. Wait a minute. If this was 33 instead of a 35, then this would be 33 over 3, which is 11 over 16. That would exactly match this. What is going on here? I'm a bit confused. Can you pause the video for a second and help me figure out what's going on? So hopefully you're done pausing the video and thinking about the problem, right? So this was an intentional mistake, and I wanted to check if you were really alert. The critical error or the scientific blunder that we just did is everything we did so far was correct, right? We found 3 squares, so the x minus the expectation of x the whole squared is 9/16, 1/16, and 25/16. Now, when we are computing the outer expectation, what we have to remember is that these three don't have equal probabilities, right? Remember why? Because 3 has a probability of 1/2, which means this square has a probability of 1/2, where P stands for probability, while these two squares come from the random variables 1 and 2, which means they have a lower probability of occurring. Both of these have a probability of 1/4. When we took a simple average, 1/3, 1/3, 1/3, we are saying all three squares have equal probability of occurring, while that is not the case, right? So what we should have done is taken the average of the areas of the three squares, but we should have used the probabilities as weights, similar to how we did it here, right? And before I made this video, I was actually trying to solve this myself, and I spent so long trying to understand why the average of the areas of the squares wasn't matching the 11/16 that I got here. And it turns out that actually trying to solve this gave me an idea for a video, and so that's how this video was born. So let's see whether it matches now. So we want to find the areas of the three squares, 25/16, weighted by their probabilities. So 25/16 over 1/4, or times 1/4, plus 1/16 times 1/4, plus 9/16 times 1/2, right? Okay, so 1/2 is 2/4. Okay, I'm going to try and test my skills. This is actually one of my weaknesses. So 25 plus 1 plus 9/2 is 18/4, right? So 18. And 25 plus 1 is 26, plus 18 is 44, divided by 4 is 11. So this is 11/16. And voila, we are done. We managed to get, whoops, okay, for some reason Notability wants this to be a square. Okay, and we are done, right? So we actually got the same number that we got earlier. So the variance computed by both the traditional way and the innovative, graphical, and confusing way is 11/16. But the point is, two main key takeaways in this video. First is, the variance can be visualized. It's not just an abstract concept in probability. It's actually the average of the areas of the squares when visualized this way. That's the first key takeaway. And the second key takeaway is, when you apply expectation to any random variable, even when you're visualizing it, you have to remember that the weights, when you compute the average, are the probabilities. So be very careful when you're taking a simple average anywhere in probability, because there's probably there's probably a situation where each of those random variables has different probabilities of occurring. So with that, I hope you found this video engaging and interesting, and I will see you in the next video. Bye.